Hello students, today we are going to learn about file allocation methods. The allocation methods define how the files are stored in the disk blocks. There are three main disk space of file allocation methods: contiguous allocation, linked allocation, indexed allocation. The main idea behind this method is to provide efficient disk space utilization, fast access to the file blocks. All the three methods have their own advantages and disadvantages as discussed below. Contiguous allocation. In this scheme, each file occupies a contiguous set of blocks on the disk. For example, if a file records n blocks and is given a block B as the starting location, then the blocks assigned to the file will be B, B plus 1, B plus 2, B plus n minus 1. This means that given the starting block addresses and the length of file in terms of blocks required, we can determine the blocks occupied by the file. In the directory entry for a file with contiguous allocations contains address of starting block, length of the allocated portion. The file mail in the following figure starts from the block 19 with length is equal to 6 blocks. Therefore, it occupies 19, 20, 21, 22, 23, 24 blocks. Now we can see what are the advantages. Both the sequential and direct access are supported by this. For direct access, the address of the get block of the file, which starts at block B, can easily be obtained as B plus K. This is extremely fast since the number of seeks are minimal because of contiguous allocation of file blocks. Now what are the disadvantages? This method suffers from both internal and external fragmentation. This makes it insufficient in terms of memory utilization. Increasing file size is difficult because it depends on the availability of contiguous memory at a particular instance. Now we can see linked list allocation. In this scheme, each file is a linked list of disk blocks which need not be contiguous. The disk blocks can be scattered anywhere on the disk. The directory entry contains a pointer to the starting and the ending file block. Each block contains a pointer to the next block occupied by the file. The file zip in the following image shows how the blocks are randomly distributed. The last block 25 contains -1, indicating a null pointer and does not point to any other block. Now what are the advantages? This is very flexible in terms of file size. File size can be increased easily since the system does not have to look for a contiguous chunk of memory. This method does not suffer from the external fragmentation. This makes it relatively better in terms of a memory utilization. Now, what are the disadvantages? Because the file blocks are distributed randomly on the disk, a large number of seeks are needed to access every block individually. This makes linked allocation slower. It does not support random or direct access. We cannot directly access the blocks of a file. A block K of a file can be accessed by transversing K blocks sequentially from the starting block of the file via block pointers. Pointers required in the linked allocation incur some extra overhead. Now in-text allocation. In this scheme, a special block known as an index block contains the pointers to all the blocks occupied by a file. Each file has its own index block. The entry in the index block contains the disk addresses of the file. The directory entry contains the address of the index block as shown in the image. Now, what are the advantages of index allocation? This supports direct access to the blocks occupied by the file and therefore provides fast access to the file blocks. It overcomes the problem of external fragmentation. Now, what are the disadvantages? The pointer overhead for indexed allocation is greater than the linked allocation. For very small files, say the files that expand only 2-3 blocks, the indexed allocation would keep one entire block for the pointers, which is insufficient in terms of memory utilization. However, in linked allocation, we lose the space of only one pointer per block. For files that are very large, single index block may not be able to hold all the pointers. Following mechanism can be used to resolve this. Linked scheme. This scheme links 2 or more index blocks together for holding the pointers. Each index block would then contain a pointer or the addresses to the next index block. Now, multi-level index. In this policy, a first level index blocks is used to point to the second level index blocks, which in turn points to the disk blocks occupied by the file. This can be extended to 3 or more levels depending on the maximum file size. Campaign scheme. In this scheme, a special block called information node contains all the information about the file, such as the name, size, authority, etc. And the remaining space of information node is used to store the disk block.